Welcome back to my channel. In this today's session, we're going to be deriving an expression for numerical aperture for a given optical fiber in terms of refractive index. So what do you mean by optical fiber? Optical fiber is a device which will be transferring the information in the form of light. On what principle it will be transferring? It will be transferring on the phenomena of total internal reflection. Now let us consider a medium. So you know that optical fiber is made up of a two layer. The one layer, that is called the center layer, is called as a core, which will be having a refractive index of n1, and it is surrounded by another layer with a low refractive index, that is called as cladding, where I have marked it as a dark side, that is called as cladding. So which will be having a refractive index of n2, and it is kept in a surrounding medium. Normally the surrounding medium can be two things: one is air, another one is water, or whatever the things we are keeping as a surrounding, that will become surrounding medium. I will be taking the refractive index of a surrounding medium as n0. So if I write this one as a form, n0 is the refractive index of surrounding medium, n1 is the refractive index of core medium, n2 is the refractive index of cladding medium. This is the initial arrangement. Now what is happening? Now I will be transferring the light from the outside medium, that is surrounding medium, and you know that whenever the light is transferring, so it will be forming an angle of theta naught. So that is the incident angle. The light will be refracted inside, so that is refraction will be happening inside, and it will be forming an angle with the axis of theta 1. And this will be noted as point A. And next, whatever the light has been transmitted in the forward direction, it will be also moving now from core medium to the cladding medium. You know that if the light is moving from the core medium to cladding medium, I want to achieve the total internal reflection, means I need to send the angle which has been refracted should be equal to 90 degree. So that I will be considering, and this point will be noted as B. So this is the initial arrangement. So this ray which I am sending, that is called incident ray. So this is my preliminary arrangement. Now I will be writing a Snell's law for the point A and point B, and I will be deriving this expression. Now by applying Snell's law for point A. So what is happening? So there is a two medium, one is n0, the surrounding medium, and the light is going for the another medium n1. How to write the Snell's law? First you write the refractive index of the surrounding medium n0, and what is the angle made? Theta naught. For that you apply sine of theta naught will be always equal to what is the angle made internally, that is theta 1. So that is sine theta 1, and what is the refractive index of a core medium, that is n1. So just rewrite this equation. Now I want this value sine theta naught is equal to n1 divided by n0 and sine of theta 1. So just rearrange this equation and take it as equation number 1. Now same thing, so whatever the light has been passed inside for the core medium will also go forward, and once again it will be refracted for the 90 degree to achieve the total internal reflection. Now I will be writing the light will be moving from n1 medium to n2 medium. So for this, at a point B, I will be writing a Snell's law. By applying Snell's law for point B. For the point B, I will be applying a Snell's law. Now what is happening? I want this angle, that is the angle of incident. You know this alternate angle will be always having a theta 1 value. Now this is complete value. So whatever the value from here to here, the value is how much degree? 90 degree. And in that already there is a value of theta 1. So what will be this value? That 90 minus theta 1 will be the value of this angle. So that will be the angle of incident from medium n1 to medium n2. So how to write? The refractive index of this medium is n1 and the angle of incident is how much? 90 minus theta 1. So apply sine 90 minus theta 1, which is equal to, for which medium it is going? It is going for the second medium n2, and what is the angle it is making? That is sine 90. So this is the equation. Now we know that sine 90 degree will be always equal to 1, and sine 90 minus theta 1 will be always called as cos theta 1. I am using AS-TS rule here. So in AS-TS rule, sine 90 minus theta is taken as cos 1. Just replace this value as cos theta 1, and n1 I will be shifting to the denominator, n2 divided by n1. And what is the sine 90 value? Sine 90 value is equal to 1. Take it as equation number 2. Right? Now here there is a sine theta 1 in equation 1, and here I have a cos theta 1 value. So I want to change this value. What I will do? I will use a basic trigonometry formula. We know that sine square theta plus cos square theta is equal to 1. So I will be rewriting this equation as cos square theta is equal to 1 minus sine square theta. Right? So I want this value in the sine terms. What I will be doing? I will be rearranging this one as sine square theta is equal to 1 minus cos square theta, and I don't want this square value. So what I will do? Sine theta is equal to square root of 1 minus cos square theta. Just I will be rearranging this one. And since my equation has theta 1, I will be replacing as sine theta 1 and cos theta 1. Take it as equation number 3. Now apply equation 3 in equation 1. Just I will be applying a equation 3 in equation 1. In the place of sine theta 1, I will be replacing this value as square root of 1 minus cos theta 1. Sine theta naught is equal to n1 divided by n naught, and in spite of sine theta naught, I will be replacing it as 1 minus cos square theta 1. Now we know already a cos theta 1, what is the value? n2 divided by n1 by the equation 2. Just apply that value as square root of n1. Cos theta value is, here there is square, you will take it as n2 square divided by n1 square, and take a LCM, and the value will be n1 divided by n0 square root of n1 square minus n2 square. Right? Now I have rewritten this equation as sine theta is equal to n1 divided by n0 by taking LCM n1 square divided by n1 square minus n2 square over the root. So what I will be doing, since it has a root, I will be removing this value as, because square and square root will cancel and the remaining is n1, and square root of n1 square minus n2 square. So n1 get cancels. So what is the remaining? Sine theta naught is equal to square root of n1 square minus n2 square divided by n0. And we know that, what is numerical aperture? Numerical aperture is a sign of acceptance angle. Means the angle which has been incident, sine theta. So numerical aperture is given by sine theta naught. If I apply this value in the previous equation, then numerical aperture can be given as square root of n1 square minus n2 square divided by n naught. So this is the equation which will be representing the numerical aperture for a given optical fiber. So where n1 stands for refractive index of a core medium, n2 represents refractive index of a clouding medium, n0 will be the refractive index of surrounding medium. Now if surrounding medium is air, surrounding medium is air, so what will be air? Refractive index of air is 1. So numerical aperture can be given as square root of n1 square n2 square. Directly I can write it. Now what is the condition for propagation? Condition for propagation means what is the propagation? So just observe. So once the light is greater than 90 degree, then what will be happening? The light will be bouncing back for the same medium. So that is, and it will be happening repeatedly and it will be moving forward. So if this to be happening, what is the condition I need to make? Now just observe, the angle of incident theta naught should be always greater than theta 1 value, means this angle should be always having more value compared to the angle of refraction theta 1. So if this angle is greater, then this angle will be bending and normally it will be going greater than 90 degrees. So that is called total internal reflection. If I apply sine on both sides for this one, sine theta will be greater than sine of theta 1, angle of incident will be, and sin theta naught by a definition I can write it as a numerical aperture should be always equal to sine of theta I. So this is the condition which will be causing a propagation in the forward direction by taking a total internal reflection. In the exam point of view, this is the most important question. Thank you.